So I'm Mike Shapiro. For the past couple of years, I've been leading our Fishworks project inside of Sun. And basically, in a nutshell, what we've been trying to do is, as sort of why we're here, right, is to reinvent our product line for storage, or really invent it for the first time. Because I think the very short history of Sun in the storage space, other than the innovation, yeah, we can just stop there. The short history of Sun in the storage space, and there'd just be a punctuation mark at the end of that. But I think basically, for those of you who've been following Sun's product line for a long time, really the history of Sun storage is very simple. Storage was something that we did that was based on rebadging or reselling other people's storage products like Ingenio and Dot Hill or other acquisitions that Sun made, because the primary thing that we were interested in doing was viewing that as something that we sold to an enterprise customer as an attach to our servers, right? That was our business with servers. Oh, you'd like to buy some storage to attach to the servers? Well, okay, I've got some products for that too, but we basically were just reselling and rebadging those things. So really, this started with the work that Jeff did about 7 years ago now, 7 or 8 years ago.
February of 2000.
February of 2000, we started to say, we really believe that this is an area where Sun ought to be bringing to bear all the innovation that we do, and that should include both our innovation in hardware and our innovation in software. And so, a very simple definition of what the Fishworks team has been doing has been off building an integrated enterprise storage product line for Sun that will be sold under the Sun's brand that is based on our core intellectual property and new innovations. And that includes ZFS as the heart of our data stack. It includes Sun's servers, but the ones that leverage commodity components like the x64 architecture like we've been talking about. It includes a whole set of new innovations to allow us to deliver enterprise class performance characteristics, but leveraging some of these commodity things around flash. And so Michael and I are going to talk about that next. And the last part is that unlike products that we sell today in the server space and the operating system space, we want our integrated storage products to be just that, namely to actually be integrated. So when you buy, if you're a customer and you're buying a storage product, for most customers today, what that means is that there's a lot of functionality they're expecting out of the box. And although many of our customers who are coming at Sun's product line from a server background might be experts in Solaris or experts in Linux and understand how to administer file systems and set up volume managers and all those types of things, we really want to not have customers have to be able to put that stuff together. We want to put it all together for them and tune it and test it and just have it be an appliance-like experience where out of the box it just works. So that's what the Fishworks team has been doing, is building, and the reason it's called Fishworks is fully integrated software and hardware that takes these commodity components and core Sun innovations like our Open Solaris kernel and builds an enterprise integrated storage product out of them. Okay? And those products are going to be announced this year, very soon to now, and that's really one of the reasons why we're starting to talk to you guys today, and we'll hopefully continue to talk to you as we get throughout the year. So one of the innovation things that we have, of course, is ZFS and all the things that brings, like RAID and snapshots and replication, other kinds of technologies. There's also a lot of other things we had to build and new things that we're doing to innovate in that area. So I just wanted to talk very briefly, because we have a lot of stuff today and we want to have a lot of questions, but I just wanted to focus your attention on a particular set of innovations that we're doing, which is around how we deliver performance and how we're changing the way that you build performance for storage, because I think that's at least one of the interesting areas where we're really doing something very different. So basically, there are really, I think, performance and performance in a storage system can be simplified down to really two things. One is, how do I build performance and what does it cost to deliver performance, right, in the storage system? And the other one is, how do I know what my performance actually is, right? So if I say to you, box X from NetApp or EMC comes with this much cache, and this other box that costs this much more comes with this much more cache, the obvious question if you're a customer is, do I need that? How much, right? What is the caching efficacy of my workload, right? And ideally, I prefer if the salesperson for that other company was not answering that question for me, right, because I know what they're going to do, but rather if I were actually measuring my workload, okay? So that's really what we've done, is to try to deliver two innovations in this area that we think totally changed the storage landscape for performance, and they fundamentally affect both the price, what is the price performance, right? What is the price performance to deliver the answer, and then also what is the customer experience for understanding performance problems. So I'm going to talk very briefly about two of those things, and basically the summary is, what we've done is we've taken ZFS and we've taken advances in flash memory technology, and we've created this new technology for building storage performance that we call the hybrid pool. The hybrid pool basically means that you are building your storage performance out of cheap commodity SATA disks, the ones that we learned are the same ones that our customer here, Mark, is using, and from an economic perspective, and we've learned from our friends at Google, have the same reliability characteristics as the enterprise class drives, right? So my unit of adding capacity is the lowest it can be. That is, my dollars per gig is the lowest it can be. But I have flash to deliver performance, and that, as I'm going to show you, really changes the model for price performance of the storage system. And then the second innovation is this thing that we call analytics. And analytics is a feature that's built into this new software stack for our storage appliances, and it's based on our award-winning dtrace technology that we developed as part of our Open Solaris kernel. So dtrace, if you've never heard of that before, is a software system that allows you to dynamically instrument the operating system in any running applications. It basically allows you to ask arbitrary questions about what's going on in the system and see the answers in real time, because it actually dynamically instruments the system to answer those questions. What we've done in Fishworks is to take that technology to the next level by building a graphical, real-time, AJAX, web-based experience for that that's tuned to asking questions that storage administrators want to ask. And this brings completely unprecedented observability to the storage system. And one of the things that's really interesting about that is that not only changes the entire dialogue around how you figure out what kind of storage performance you're getting, what kind of capacity planning you need to do, but it also tells you something much larger about what's going on in your enterprise. Because the storage system, right, if you have what we think of as an NAS box today, that's actually a nexus of activity, because potentially hundreds or thousands of clients are talking to it. And so if you can observe everything that a storage server is doing, you not only are learning about that box, which is something you've spent a bunch of money on and is very important in your infrastructure, you're actually learning something about potentially what hundreds or thousands of other machines are doing. And so with the power of dtrace, administrators can just walk to the box and ask questions like, could you please, so let's say I'm serving files, CIFS, NFSI, SCSI. You can start to ask very basic questions, and if I'm just going to read you some questions, forget what this looks like, but just imagine the following list of questions. Okay, so of the three protocols, which one of them is consuming the most bandwidth rate? Okay, it turns out CIFS is consuming the most bandwidth. Which Windows clients are consuming the lion's share of that bandwidth? Okay, now that I've identified those clients, I'd like to take this client over here and ask the question, which files in my file system over the CIFS protocol are being accessed that's consuming all the bandwidth? And now I'd like to know, what's the mixture of reads and writes to those files? And now I'd like to ask the question, what's the ratio of cache hits and misses of those files? Okay? Now, what I just listed for you are, even if you don't know anything about the implementation details, those are 5 or 6 very basic questions that any storage administrator, any person who understands generic capacity planning and computing would want to ask. Take any storage product on the market today, you wouldn't even get past the second question. There's absolutely no way to answer any of those questions. You would have to have a team of 15 people from the vendor to come out and install the special debug operating system and the special tools that they don't give customers to even get halfway through that list, if you could get halfway through it. And so analytics is completely transformative, because it actually allows a person who understands storage, but not how we built it, to literally point and click their way through those questions in a web browser and understand those questions for themselves safely, live, and in production on their running storage system.
Yeah, I think a moral equivalent, because a lot of you are professional journalists here, would be you submit a story to your editor for publication. Nope. And that's all the feedback you get. Can I ask you what you didn't like about it? Nope. There's not even a language to ask that question. Yeah. Right? You just have to try stuff and then say, how about this? Nope.
And those are the problems that people deal with storage systems every day. And I'll give you one anecdote. I was talking to a reseller of ours yesterday, and he related a very sort of, this is a common story that we hear. These are the kinds of things that people who have storage systems deal with, which is he said, I had this customer, and I won't name the competitor, but a NAS box vendor who exists today. And we set up this product for him, and what is he doing with it? Very common use cases. He's building storage over Ssd for virtual machines, right? So he has VMware, and he has this NAS product, and set up hundreds of virtual machines on the thing, and we set it all up for him, and it runs great. And it was able to boot, his VMware instances in, 45 seconds or whatever, right? And so we set that whole thing up and we left. And then a couple weeks went by. And over those weeks, the boot time of virtual machines got slower and slower and slower. And now the virtual machines that used to boot in 45 seconds or a minute are now booting in like 30 minutes. And they have no idea why. And all they've done is they've debugged the fact that it's not their network. They know the problem is in the storage system. They know that for some reason, the set of storage traffic flowing from the filer back to those clients is significantly slower than it used to be. They have no way of understanding that problem, right? Is it because it used to be in the cache and now it isn't? Is it because they scaled too high? Is it because they're out of CPUs? Is they're out of I/O bandwidth? They have no way of knowing that. So analytics is really one transformative thing, and then the other thing is this hybrid pool and how we build storage performance. So that's the one thing I want to show you a little bit more detail on. So let's go to the next slide. And this really connects to what Michael's going to be talking about, which is about our relationship with flash vendors. So there's really two parts. Oh, sorry, go ahead.
Is this hybrid pool stuff, is this special to Fishworks, or this is just...
Well, what we've done is we've taken, so you sort of think of as we're building these things out, we have our Open Solaris kernel, we have ZFS, and then we have Fishworks software. So what you have basically is the core ZFS assets, okay, which includes the technology of ZFS, a core set of data services like RAID and snapshots and mirroring, and how ZFS, there are some changes in there in terms of how ZFS can use certain kinds of flash devices that we've put into the open source ZFS base. In fact, some of these things are already available to people. They don't necessarily know that they're there, or that they might have, unless they're hanging out on the Open Solaris mailing list, they might not know what it's about. But what we're doing in the integration layer is, for example, when you buy the product from us, you just want it to automatically discover all the flash devices that there are, and you want it to know which ones are for read optimization and which ones are for write optimization, and you want it to configure all this stuff together into the optimal performance configuration. Well, that's part of what it means to do the integration activity, and that's the part that is specific to the integrated products and the software that comes with that, as opposed to just what it means to piece it together yourself, right? Does that...
Yeah. So. And in some ways, it's as simple as the assumptions being different. Like if you have just a general purpose computer and you plug in a disk drive, you really don't expect some piece of storage software to just go bogart that drive and start doing what it sees fit with it. Whereas with a storage appliance, if there's an open slot, you actually do expect it to do that.
So basically for performance, and this is going to tie into what Michael's saying, but just to briefly explain this hybrid pool, I'm just going to show you a quick example, one piece of data about what we have from it before that we've published with one of our partners. So basically, in the world of storage performance, there have been for the past 10 years 2 ways to build performance into a storage system. One of them is to add a lot of cache, which is to say a lot of DRAM or NVRAM, whether it be used for read cache or write cache. Okay, so if you buy a lower-end NetApp system, you might get a gigabyte or 2 of cache in the form of NVRAM for write cache, or a gigabyte or 2 of DRAM on the controller node for read cache. And if you bought a giant system like an EMC DMX, you might be getting a terabyte or 2 of cache. Okay? And then the other thing you do is, instead of using slow, cheap disk drives, you use really fast disk drives, the 15,000 RPM disk drives, right? And if you want to make all your data go really fast, you can take that model even further, and you can use a technique that is known in the industry as short stroking disk drives. And what short stroking disk drives means is that basically if you have your spinning disk drive, if instead of using all its capacity, you arrange all your data around the outer tracks, then you further reduce the rotational latency to get that data. So what you're doing is you're over-provisioning on capacity in order to further gain on performance. And in fact, and this is kind of a fun little exercise, some of you may already know about this, is if you ever want to know how it is that the storage vendors have fun with the benchmark numbers, go look at any storage benchmark, like all your typical SFS numbers, and look at how much data was the benchmark using and how much storage did they provision. And you'll notice those 2 numbers are off by often as much as 10 or 16x, right? Sort of like, here's a terabyte that we're benchmarking, and oh, by the way, you were supposed to have 16 terabytes of storage. Right now, why would any customer, and we just heard from one in terms of what was his cost point, why would someone said to you, you have a terabyte of data, but I'd like you to buy 16 terabytes of my storage, you would laugh them out of the room. Except that's how they're making that's actually an example of this short story being at work. That's how they're making it go fast. And by the way, so take a picture of that. This is the first time someone has taken a picture of my star office. I'm extremely proud of that right now. Take note of that. All right, go to the next slide.
Okay.
So that's the way that we did that. Okay, so here's the big change. The big change is that we are going to be the first folks to use Flash, not the first folks to use Flash, but the first folks to use Flash in an interesting way in storage. And what that means is we're going to change our software to do something special with it, and that's the hybrid pool. Okay, so yes, you can take Flash, you can make a thing out of it called an SSD, and you can put it into a traditional storage system and just offer it as another kind of disk drive that you can plug in. Okay, fantastic. Why did you do that? Because you didn't have to change your software stack. That is not very interesting to do. Thanks for reminding me not to blow up the projector. What's more interesting to do is to start to use this integrated with the software, and that's what Sun is going to be doing. So here's the background on Flash. The background on Flash is that it used to be really, really expensive. And then, thanks to all those iPods and cell phones that we all have, the volume of that market and the economic force of drug have been driving the price down and the density of it and all those good things that we like, all those nice doubling curves that we like in the commodity space. But Flash has some interesting properties, and the interesting properties are that it's very, very fast to read, but much slower to write. And so in order to use Flash in an enterprise class storage system, we have to do some more interesting things with it, both in the hardware side and the software side. So for the hardware side, what you have to do basically to do something interesting with this is that we actually put some kind of smaller amount of buffer or cache in front of that. DRAM or SRAM, and what that does is it hides the latency of the time it takes to write Flash. Okay, and then what we do is instead of just having one channel of Flash, we can actually have a whole bunch of channels of Flash operating in parallel. So you can have more than one transaction outstanding. It's all the same tricks we use in memory and disk drives for other things. And then what we can do is we can put an energy storage module of some kind, a so-called supercapacitor, next to the device and the DRAM buffer. And what that does is it has enough charge in it so that if the system loses power, that buffer that is taken to write can drain into Flash where it becomes non-volatile. And so if you do all those things, what you end up with is something that has the Flash commodity curve, is non-volatile, is really, really fast to read, and is also really, really fast to write. And that is a new building block, a building block that we can put in a variety of different form factors to start to build storage performance. Now the next thing is, then we're going to go change ZFS to make this thing that we call the hybrid pool to take advantage of that. All right, so let's flip to the next picture, and I'll just show you this very briefly. This is a slide first, just a very quick picture to show you why we changed the software. And this is economic data. So this is as of 8 months ago or so, but this is one graph of performance. And what this is showing is, in the lightest blue, DRAM, a read-optimized Flash device, and the fastest disk drive on the market. And this is performance, and this is price. So what you're seeing here is that something very unique, which is, in both price and performance, Flash is actually forming a unique location in a memory hierarchy, in a caching hierarchy. Right? Which is to say, the optimal storage system for performance, the one that gives you the best bang for your buck, is going to be the one that has the right balance of these three factors. Right? Don't care whose product you buy, right? Believe our story or not. That is the economic evidence for why this is the most dollar-efficient way to deliver performance in the storage subsystem. But you have to change your software to take advantage of it. Let's go to the next picture. So what we've done is we've built this thing into ZFS called the hybrid pool. And the hybrid pool does exactly what I just said. It builds a uniform caching architecture where ZFS has all the smarts to manage the storage, where you have your big pool of SATA devices. And again, forgive my limited skills with Star Office here. No one will be taking, you are taking a picture of the slide, thank you. That's a pity shot though. My big purple circle. So what you have is basically a big, huge pool of SATA devices. So the unit to add capacity is the lowest possible dollars per gig. It's the commodity component. And then what I have is transparently managed by ZFS along with that is some amount of read-optimized Flash, some amount of write-optimized Flash, and some amount of DRAM. And every component here, every component is a commodity component that has the volume economics that we want, which is to say it's doubling in density every 18 months and lowering in price. And then our software architecture is allowing you to take advantage of that. And so what this results in is actually you kind of can have your cake and eat it too. Overall, the hybrid pool delivers the best dollars per IOP, the lowest dollars per gig, and also, here's the kicker, the lowest watts per IOP, the lowest watts per megabyte, and the lowest watts per gig as well. It's the lowest power, and that's because one of the differences between those fast spindles and the big amounts of DRAM is also that those are the two most power-hungry components you can put in the system as well. So when you build your performance this way, as opposed to that picture that I showed before, you're now taking the biggest thing you have, right, your unit of capacity, and you're using the lowest power disk drives, as opposed to those power-hungry 15,000 RPM disk drives. Okay, so that's our big innovation in performance. And then that couples and becomes really a self-reinforcing positive cycle with analytics, because we're also giving you the tools to understand how much of this do I need? Am I getting any benefit out of it? Do I need more read cache? Do I need more write cache? You have to have the tools to answer that question, and hopefully it doesn't involve 20 of our service personnel, running an experiment for you back at Sun, but rather you looking in real time at your production workload. So I'm going to show you my last picture here, and then Michael's going to talk some more about Flash, which is to just show you one quick example with some data of this actually in operation. These are two slides that we published with Intel at the Intel Developer Forum in Shanghai. Intel is, of course, producing flash devices, and I'm sure you guys have seen some of the press releases they've done around that. They're one of our partners in the flash space, and Michael's going to talk about that a little bit more. And what we did to be on stage with Intel at Shanghai is we did a very small example of the hybrid pool in action. So what we did is we took one of our two servers, of course, with Intel processors in it, so we could be at their conference, and we took just 7 disk drives, because this was just a little server, so we had one boot disk, and we took the other 7 disk drives, and we made 2 configurations, identical hardware, same ZFS, right, so we make the same configuration, and we took 7 disk drives, and we bought the fastest IOP-oriented disk drives you could buy in the market today for that, which would be the 2.5-inch, 146 gig, 10,000 RPM disk drives, right, from any vendor you like, Seagate, Hitachi, whatever. And then, for configuration B, we made a sample hybrid pool. So what we did for that is we bought one write-optimized flash device, in this case one of Intel's, one read-optimized flash device, again one of Intel's, right? So we have both read and write-optimized flash devices in our hybrid pool. And then, for the raw capacity, we took the other 5 disk drives and we picked the slowest, cheapest possible drives we could find. These were 4,200 RPM, right? So less than half the speed of the others, right? But 400 gigabytes because I get more density with those. And to build these 2 configurations, same server but different drives, we spent the same dollars, same amount of money. Okay, and let's go to the next slide. And this is the results we announced with Intel to show this. So blue is the hybrid storage pool, and yellow is the traditional. Okay, so with this architecture, same server, same operating system, right? ZFS. But these 2 different drive configurations, this is what the hybrid pool did. Basically, we won on both read and write IOPS. This is, in this case, measuring just random 8K read and write IOPS. We spent the same amount of money, but by the way, not only did we win on performance, we used 1/5 the power. And, by the way, you also got 2x the raw capacity, because you weren't buying the small, really fast disk drives, you were buying the higher density, cheaper, slower spindles as your unit of raw capacity. So this is a very compelling example of what the hybrid pool does. And this is at little bitty scale, 7 disk drives. Okay? So when we talk about what we're doing with Fishworks, what we're doing with our integrated storage projects he announced, this is what the hybrid pool does. What our enterprise storage products are going to do is do that at really big scale, right? At enterprise class scale, hundreds of terabytes, and more. Okay, so that's big innovation in terms of price performance, and then Michael's going to talk some more about Flash. I don't have any more questions about this right now.
Well, I mean, last time we talked, I think you guys said you were aiming for like February with Fishworks, so I was just curious what's.
Well, the engineering schedules change a lot, and we have, of course, there's always the game of who thinks what's going to be done when. But yeah, we are launching these products this year.
End of this year.
Yeah, end of this year.
But
yep.
I mean, does that mean is anything changed or something added? Or?
I think that we have to, it's very important to us obviously in building any sort of integrated storage system. I don't think our schedule is ever February, but I think that in building any system like this, there's a huge number of dependencies. And one of the things that we really believe at Sun is that storage is a trust business, and we're not coming out with a beta version of an enterprise storage product. We're coming out with an enterprise storage product, and what that means is it has to work, and the quality of that is extremely important to us. And also, we have a lot of new technology here, which is changing very rapidly, including some of the things Michael's talking about in the flash space. And so, we're really looking at being able to get the best kind of launch we can get in terms of getting all the factors lined up. And so, we're working very hard on that, and it's going to be very gratifying to be at the launch for this in another month or so, as we get into that.
And you have to use this framework on top of Solaris. You can't do like a Linux system?
So that's a good question. Let me just clarify sort of the form. So I think I said at the beginning, but in terms of what we're building, but just to clarify, right, is what we're introducing here is not only some additional technologies that are part of our open software base, but this line of integrated products. And so what that means is you literally just buy a part number from us. I want the Sun Storage XYZ, and it shows up, and the software's already installed, and it's an appliance, and you log into our web interface, and you go. There's no operating systems installed, there's no OS to administer, there's no SE files to edit, it's just a storage appliance.
But I mean,
That's
if
it.
this is all open Solaris and stuff, I mean, so it has to be tied to that hardware, because I mean, otherwise people could take the software and do whatever they want.
Well, we of course want to encourage folks, so part of our open source thing is we want to have a bunch of technologies also that people can see the source code, participate in the development of, so we'll do that as well. And then another part is that we may do licensing deals or other things with other people who want to be able to take advantage of some of our software innovations, but on other kinds of hardware, which might be customers doing it themselves or other things. But obviously, when we talk about the storage space and some of the things I just told you about Flash, what you see is that we're also hoping that there's a value associated with buying our integrated products, and that's that we've fit all those pieces together, we've tested them, it's connected to our phone home services and all the things that you'd expect from an integrated product. So folks can take advantage, there's sort of different levels to buy in at here, and it depends what you're trying to do. If somebody like Mark with a huge amount of expertise has gained, you sort of heard the story, but he's gained such a huge benefit just from being able to take commodity components and take a ZFS technology. But at the same time, I think that if we can deliver him that brick, but already integrated and tested, maybe with Flash and other performance things, and by the way, he still gets the same commodity values, there are also more interesting other things up the stack that he can go work on as well, right? And then also there's the broader audience of more traditional enterprise customers or people who just, they don't necessarily have the kind of expertise that Mark has, who just, okay, I want the storage brick, but really, right? And I think that's sort of a good segue. The last thing I'll say is that I think what we see in the market is that for most customers today, one of the really interesting things happening is storage is actually not their business, right? Unless your name is Iron Mountain, storage is actually not your business. Your business is something else. Mark's business is music. YouTube's business is video. However, storage is actually the biggest cost center and the limiting factor in the growth of the business, right? And so that's really, I think, what we're trying to do with these integrated storage products is give people these building blocks that everyone's used to, but let them leverage the commodity economics to do that. And a lot of the new innovations that we're bringing around price performance with Flash, right? But in the enterprise package in the way that they're used to, because actually their business is about something else, right? And we want them off working on that, and yet not having storage drag down the cost, drag down the complexity, make it impossible to scale the app because they can't figure out what the performance of the storage device is. And that's where I think we see most customers struggling in this area today.
So I think with that, we'll have Michael talk about
Yep.
Flash. That was great, Mike. And then we'll time for all this to wrap it all up.
Can I ask just one more question?
Yeah, sure.
I gotta run out of here. Sorry. I mean, is there it just seems like there's a flaw in you guys' theory when you make the x86 Linux comparison, because when you're saying, these people don't want to do storage on their own, they want to concentrate on the regular business, and with Linux you had that whole momentum of all these this bubbling up momentum that helped push it into the enterprise. So there has to be if you guys are doing something different at some point, there has to be something that makes you walk away from NetApp, which, like for Linux, and people moving away from you guys, it was kind of...
Yeah, well, I think, let's sort of take apart, I don't want to spend too much time answering this, but just to kind of take it apart into two things quickly, right? So there's really two things we're saying. One of them is that there's if you win big on price performance, then it turns out that you can be very disruptive if you have 90% of the features that people want. Right? So we believe we have a bunch of new storage products. We believe they have 90% of the features that most people want, and we can get people literally an order of magnitude win on price performance. So what that does is it allows you to disrupt and change the market, get people thinking differently. Then there's a second part, which is you'd like people to be able to, people who are real experts, people who have energy, people who want to access to source code, want to be participatory in development, et cetera. You want to be open for them. And that's another thing that is totally missing in the storage space today. Right? And so to me, those are sort of two different stories, but they're both lessons that we've learned from other disruptions that have happened or things that happen in Linux and Linux. So, you know, they're separate to me, but they're complementary.
Okay. Thanks. So is this the...
Yep. So I'm Jeff and Mike have talked about the software piece of what's happening with open storage. The piece that I'm going to talk to you about is some of the technology that we're developing in order to create this new market around NAND flash. And NAND flash has been, as Mike mentioned, it's been around for since the early 90s and has really been a focus of consumer applications and how they could enable a better class of performance and really disrupt technology from CDs to print media to all these other things as far as photos and what flash can do in those markets. And I think that what we're seeing is that we're seeing the adoption curve and what everyone likes to talk about with the buzz is the notebook market and what the displacement of the disk drive can do in that space. I think what we're saying or what we're looking at here is, well, how can we use this technology in the server market and in the storage market? And I think that's the piece that, again, Mike and Jeff and ZFS have a very compelling story on what software can do. What we talk about here is what is the anatomy of what people consider an SSD today. And what a lot of people get really confused about the difference between flash and hard drives and SSDs and what they are. And I just wanted to go through sort of a quick high level because it really tells to what we're trying to do here. And what we saw when we first looked at this market was there was no one really trying to address the enterprise or the server class SSD market from a flash commodity point of view, from a controller point of view, and that's what I'm really spending a lot of time looking to solve. And so you have three major building blocks to a storage device. Is you have the actual media itself, you have the controller, and then you have the interface of the host. And I think we spent a lot of time talking about how the host talks to these types of storage devices in our storage servers. But the key pieces to really what a storage device is the media and the controller. And the real differentiation between a disk drive and a flash drive is really one has this, what we like to call it sun, the spinning rusty thing, and the other one has a silicon storage solution. And that's one of the major differentiation points. The controllers are very similar. They both do the same thing. They provide an abstracted user interface. They both do bad block management. They both do caching, performance, and everything necessary to sort of maintain that media and to keep that media from hurting itself to provide, again, the customer or the host that abstracted interface. And I think this is a very important thing to start with, is because most people, when they think of SSDs, they tend to forget about the NAND, or they tend to focus on the NAND. And they typically forget about what the controller is and what the controller does. In a disk drive, the most important thing is the controller. The media is the free cheap part. Yeah.
So it looks like the controllers differ in terms of the fact that flash has a different repair cycle. Could you talk for a second about what kind of problems occur with flash media?
My next slide actually goes into some detail on flash and some of those problems. I think that the difference that you see here is that, yes, you have the wearability of the controller, but hard drives do something that's it's a lot more difficult, which is they have to try to keep a little small disk head on a track. That is, as Jeff mentioned earlier, you're flying at incredibly low tolerances to the media. These track pitches are getting incredibly small, hundreds of thousands of tracks per inch. And it's an incredible difficult thing that hard drives do. And what happens is a lot of people just take this for granted. And I think that's one thing that, talking about wear out of flash and those types of things, that people tend to forget that their disk drives have all the same sort of issues that these flash systems have. It's just we've all learned to live with them and typically have forgotten about them. So, for example, like wear leveling, disk drives have the same thing. You can end up fringe writing adjacent sectors if you write the same sector too many times. And a lot of people just sort of either don't know that or they tend to forget it.
And what kinds of defects you need to manage at the flash level that those are built to control there?
Yeah, so I think if we go to the next slide, we'll talk about what we've done from the media standpoint. And what we've done is there was an announcement that came out, I think about a month ago, where Samsung announced a joint development effort we had with them on what we call server-grade SLC. So what happened was, when we first started looking at the NAND market and looking at the quality of devices that were available in the market space, we started to notice that 90% plus of the flash market is focused on consumer devices that typically, when you have a failure condition in a consumer device, you simply toss it out or you send it back to the vendor and they send you a new one. And so what we decided is that we need to go off and really try to define a new type of NAND flash for what we consider 7x24 I/O intensive applications. And so we went to the market leader in flash, the largest producer of flash in the world, which was Samsung, and we started a program where we developed a derivative of their current single-level cell NAND flash to enable for a higher reliability, higher endurance, and a higher performance part. And that's what Samsung announced about a month ago. And I think the key here is that it took very dramatic enhancements to that die. There were full metal mask changes. There was test process changes that had to occur. There was a lot of qualification that we had to do with Samsung on this device in order to hit this 500,000 write array cycle limit, which we announced. So I think what we're trying to do is very different than a lot of people in the coming into the SSD market, which is they're trying to better manage the flash. What we did is we took a different approach. Is we came in and said we want to build better flash so that we don't have to rely on the sophistication of the controller. So I think there's a lot of types of generic flash failures that we worked with Samsung to figure out how to screen out at their factory or how to have better detection at the die level. So does that answer your question?
Well, it was more generic. It was what kinds of problems would occur in flash? I'm not that familiar with the process.
I think there's...
You might want to describe maybe just like what a flash cell, just kind of how it works. You maybe just do a little diagram with a little island of charge.
I know that it's no state, but the question is, does it fail after some writes, or is there a quantum effect that makes the information unreadable? I just don't know.
I think there's all of those issues, which is that with flash cells, it's a technology where you're trying to isolate electrons in a gate, and you have this oxide layer around it where you try to protect the electrons from leaving that gate. And so anytime, the basis of the technology is to use high voltage to try to entice electrons onto that gate. And as you do that, you could burn out the oxide so the electrons leave. After a period of time, the electrons just sort of disappear on their own. And that's sort of the two things that people talk about when they talk about flash endurance is how long does the data stay there and how many times I can write it. And it's really a two-variable formula, which is the more times you write it, the less likely your data is going to stay there over a period of time.
And that's really, just to be clear, what they mean there, right? So when you see something, or when Michael says something like, this is a number of write array cycles that's certified, what that actually means is they're saying that there's effectively a never-ending life cycle of your bit being non-volatile. And if you write erase that page more than that number of times, it is likely that the oxide layer has worn out, where they can no longer guarantee that bit will live there for that life. And so at that point, you consider that page or that cell to have failed. That's really what's going on there.
Just one more question to get clarification. You're doing a lot of writes across the entire array. Does that failure happen evenly across the array? Was that a threshold that happened randomly?
It is a random failure. Okay. Similar to what you have with the disk drive. After a period of time, disk drives will randomly fail.
But the important part here, and this is where the key word there is when you read and you'll see people talking about, and Michael will talk about wear leveling. What that means is in the firmware, they're keeping track of how many times they've written and erased the different pages. And what they're doing is they're taking the logical blocks as presented by the flash device and moving them around so that the amount of wear on any particular page is roughly speaking even, so that you don't have particular blocks failing way before others based on the access pattern.
Now, ZFS has some very good capability with wear leveling systems in Flash because of how it does its write operations. It's actually better for wear leveling systems in these SSDs because it does a copy on write instead of always trying to do a write in place. And that helps the wear leveling system have an easier time of managing the bad blocks or the blocking system in order to make sure that it doesn't end up with lots of bad blocks, as well as data fragmentation.
Yeah, I mean, the other thing that's fundamentally different for us is that the way we're using Flash, remember Mike was describing we have both read and write optimized. The write optimized is used as a transaction log. So the purpose of writing to it is simply to put the data someplace non-volatile for the 10 or so seconds between right now and the time it gets written to disk. So it only really needs to be non-volatile for on the order of seconds, even though Flash is actually non-volatile for on the order of years. The other thing is that for the read-biased Flash, we use it strictly as a cache. So you could actually lose the entire contents of your read-biased Flash, 100% of it, and you haven't lost any data at all. It just will go a little bit slower as you have to fetch it from disk drives instead of from a Flash device. So we're not actually storing data persistently on Flash. We're just using it for the performance characteristics. And on the write side, to lower our latency, and on the read side, as basically a really cheap, cost-effective DRAM extender.
We've developed this Flash to go a step beyond that, which is that this could act as a replacement for a disk drive with server-grade SLC. And that's one of the main reasons that we developed it.
So it's through those
Yeah.
much use of
Yeah.
scale.
Yep. Yep.
So you worked with Samsung to put together better media, but you haven't ignored the controller, right?
Yes, and that leads into my next slide perfectly. Thank you. The other thing, and this is the first time we've talked about this here today, is one of the biggest problems with an enterprise SSD is what we consider the problem of the commoditization of the enterprise SSD, which is today most people that are considered enterprise SSDs came down from the military market, where Flash has been used for a number of years in lots of different military applications, weapons of wars, spy planes, all the above. And what we're seeing is that in order to use this technology, we have to use something that's a step above what is considered the consumer SSD controller, because all they care about is price. They don't care as much about performance. So what we did is over a year ago, we went to the leader in hard disk drive controller technology, and that is Marvell Semiconductor. And we started working with Marvell on developing what we call a commodity enterprise SSD controller, which is use and leverage what Marvell is great at. And Marvell has shipped over 1 billion hard disk drive controllers to date, and use that cost and use that infrastructure, use a lot of their IP in developing a low-cost integrated system on a chip. And what we brought to the table is we took and looked at their existing consumer type architecture and added a lot of robustness or a lot of enterprise enhancements to it, like advanced fault detection for things like that we have with ZFS and FMA, and having some self-healing characteristics of flash drives that typically aren't available in consumer flash drives. As well as we gained a lot of the things that are very tough about SSDs, which is the interfaces themselves, the SATA interfaces and the SAS interfaces, are not trivial problems. And they have solved those problems for the disk drive world, and we're able to take that logic and that IP and SATA PHYs and SAS PHYs and have compatibility today without having to worry about some of the issues that happen with other SSD controllers.
Oh, you were saying SATA PHYs. I thought you were saying like SATA PHYs, like
No.
to like SATA eyes.
Those So, well, SATA eyes is one great example of a problem. Is the configurability of a Marvell SATA PHY or a SAS PHY is dramatically better than you would see from somebody who's working on their first generation or just buys an IP block from a standard IP vendor. So there's a lot of the technology enhancements that we get from Marvell simply because they're in the disk drive business. And I think the key point here is that we're able to eliminate the need for expensive custom hardware and FPGAs, which are commonly seen in these quote-unquote enterprise SSDs, so that we could deliver a very cost-effective, high-performance solution.
So I think the other thing just to mention here briefly, is that if you sort of think about, right, so what's different about what Sun is doing with Flash from what other vendors can do? And one part is software changes technology that's allowing us to use it in a different way. And another set of changes is around the actual devices and what we're building, but also because of the two partnerships that Michael's talking about, that is also giving us a different kind of economic advantage in the marketplace, because every other person, vendor who wants to do something is basically going to a SSD vendor and buying a device from them. And they are going to the market and buying flash chips, right? So the flash vendor is selling an SSD vendor flash chips, markup number one. The SSD vendor is selling the storage vendor those same flash chips wrapped up in an SSD, markup number two, who's then selling that device to the end customer, markup number three. And because of the partnerships Michael's talking about, we've actually eliminated one of those markups between our devices and the end customer. So that's going to result in very competitive price offerings for and then also with these enterprise innovations connected to our software stack.
And I think that brings up a great point, is that SSDs have been around for a number of years, and the key barrier to SSD adoption has always been cost. And that's the number one thing that when we developed our SSD strategy, we went after trying to make it a cost per performance solution, rather than just trying to roll a bunch of SSDs into our systems as a buzz thing. So again, we're focused on the cost of these devices as much as we are on the performance of them. And that's why we've taken this model, as opposed to, as Mike said, just buying a quote-unquote SSD from somebody and putting it into our system. So this is an interesting slide. This slide has been is over a year old inside of Sun, and this is one of our early slides in looking at how SSDs or how flash ends up being used in systems, and a lot of this is public knowledge today, and sort of how the flash industry is going after solid state. And what we see, one of the reasons that we showed you this, or we're showing you this, is because this is what we're talking about in the market today, and this is sort of the difference between what traditional storage vendors like to talk about when they talk about SSDs, and then what we like to talk about when we like to talk about flash and integrating flash into our systems. And I think the key point here with open storage is that we're able to get flash through both hardware and software verticalization, get flash closer to the CPU to get to realize the performance benefits. And as you see that today we're sort of in this HDD replacement, is 5 to 10 years out from now, you're going to see sort of the integration of NAND as close as possible to the processor, similar to what you see in DRAM today. And the key benefit there is that you're able to utilize and realize this performance, but the guys that are going to be able to do that have to have the software integration. Without the software-hardware integration, in order to get after that, you have to wait for standardizations to happen. You have to wait for Microsoft and the Linux communities to sort of sanction that, okay, we're going to spend some time doing that work. And that's something that we're able to do very aggressively from the hardware side, what I'm doing on a flash or a controller level, to what Mike is doing from a product standpoint, to what Jeff's doing from a software technology point. All of it is integrated. The three of us work very closely together to sort of build these technologies. But I think that's where there's been this classical argument in the press and in a lot of, was at a trade show or flash technical symposium a couple of weeks ago, and everyone was talking about, is flash a replacement for disk or is flash a replacement for DRAM? And the answer is well, in some instances, it's going to be both, and that's where we're going to see, I think, the market diverge as we have the legacy storage design methodologies versus what we're trying to do with open storage. So
Good. Well, great. I think actually we're going to wrap it up there. And other questions you guys might have, well, we're going to make our way to the next bar. Yeah. to bar. And so save them up. I know that there's a lot of information to digest. If there's other specific questions, we'll just find time over there. And we've actually got cabs. Nadia and team have organized some cabs, so we can just all just head downstairs and we can all. Went to a place called Rye. It's a bar that's a short cab ride away, and then we can all ask